My dear friends, welcome to Rajashekhar classes on applied data science. This is lecture number 394. In this lecture, we will try to understand KL divergence. So now let's learn about a very interesting function called Kullback Leibler Divergence, often referred to as KL divergence. So we will learn it is in the context of entropy. We will try to understand KL divergence in the context of entropy. So question is simple. Imagine if I have two distributions. Again, these are two PDFs or PMFs. If it is continuous random variable, I can say it is PDF. If it is discrete random variable, I can say it is PMF, isn't it? And we want to what we want to compute is what is the distance between these two probability density functions P comma Q. This is one probability density function. This is another probability density function. What is the distance between these two probability density functions P comma Q? How do I say whether these two distributions, these two density functions, whether they are same or not? Again, remember these two P comma Q are functions of X. P of X is probability density function on continuous random variable X, and Q of X is also Q of X is also a function that is probability density function on a continuous variable X. Given any two distributions, can I compute the distance between P comma Q? Our intention is we have to find distance between P comma Q. If this distance between P comma Q small, let me assume this is small. If both the distributions are same, if the distance between P comma Q is small, I can say this. If they are small, then what is your conclusion? The distance between P comma Q is small if both the distributions are same. Imagine if P and Q are almost overlapping, then the distance should be small. If they are more different, as P and Q are very, very different, then the distance should be large. That's the whole idea of any distance measure. Now, how do we design something like that? Now, before we go into KL divergence, let's look at techniques like you already learned, you are already studied. KS statistic, this I already discussed. KS statistic, isn't it? Try to recall that lecture. We studied about K statistics, isn't it? What does this statistics say? This is an idea that we already learned. Let's try to use the compute the distance between two PDFs. Let's use something like you already knows that K statistic. What is this K statistic? Let's use something like you already know K statistics. See, that works. If it doesn't work, why it doesn't work? Isn't that we should understand? Let's understand the importance of KL divergence. Imagine I have PDFs P and Q. Let me say I have PDFs P and Q. Let me assume I have PDFs P and Q. I have PDFs P and Q on a random variable X. So given PDF P and Q, I can always compute CDF. If I have PDF, I can calculate CDF, isn't it? So given PDFs, I can always compute CDFs. P dash is CDF corresponding to P. Just see, this is PDFs, this is CDFs, isn't it? How will I get? What is this P dash? This P is PDF, corresponding CDF is P dash. This Q is PDF, corresponding CDF is Q dash. This is Q dash, isn't it? What does it mean? P dash is CDF corresponding to P, Q dash is CDF corresponding to Q. Now what does K statistic says? What is the definition of K statistic? It is the supremum. Just try to recall K statistics. Supremum, sup of. It is the supremum or maximum of P dash x minus Q dash x. It is the maximum value for all possible values of x. For all possible values of x, you have to calculate P dash x minus Q dash x. You have to identify maximum value. It is a maximum value for all possible values of x. For all possible values of x, I can compute P dash x comma Q dash x, whichever is the supremum. Whatever is the maximum gap, isn't it? Maximum gap becomes that maximum gap. For all possible values of x, we will calculate P dash x minus Q dash x, that maximum gap. What is that maximum gap? That is K statistics. That maximum gap, what is this? This maximum gap, max gap becomes, what is that maximum gap? That is Ks statistic. This I already discussed, isn't it? K statistics is sup of P dash x minus Q dash x. Obviously, K statistics is a very good measure because the more different the two distributions P and Q, if they are more differ, there more gap. There will be more gap between its corresponding CDFs. Means if P and Q are more different, their corresponding CDFs will have more gap. The more similar, if P comma Q are similar, the more overlapping. You can find overlapping in between P dash and Q dash, isn't it? The more similar, the more overlapping. These two distance functions are more overlapping, isn't it? This will be P dash and Q dash is similar. P dash, the distance between, if this P and Q are similar, the distance between P dash and Q dash is smaller in the K statistics. It is simple. If P and Q are similar distributions, the distance between P dash and Q dash is smaller in the K statistics. I can use K statistics as a distance measure. One can make use K statistics as it is a distance measure, isn't it? I can say I can use K statistics as a distance measure between two PDFs, isn't it? It's a distance measure between two PDFs, P comma Q. I just compute their CDF. I take the supremum. This is certainly one possibility. But what is the problem with this? When we have K statistic, the concept you already studied, why are we again studying KL divergence? It's a very good question, because look at K statistics in some of the machine learning algorithms that we studied till now, like look at logistic regression, look at all the optimization problems. I need to be able to compute the derivative. For me, what I need derivative, isn't it? I need derivative. I need to be able to differentiate functions. I must be able to differentiate function. I must be able to differentiate functions, isn't it? Imagine if my distance measure is K statistics, which is a supremum of P dash x minus Q dash x. Can I differentiate this function? This supremum of mod. This is mod function. That is important. Absolute value function. We already we know what is absolute value function, isn't it? Given two functions, given P and Q, I can write supremum of mod of P dash x minus Q dash x. Supremum of absolute value of difference between these two P dash x minus Q dash x. The difference between these two functions is it differentiable? Absolute value. Mod x is not differentiable. Mod x is not differentiable at 0. Isn't it? It's continuous, but it is not differentiable. You can see this graph like this, mod x. Isn't it? It is not differentiable. We have problem with absolute value function. We have problem with mod x. How do you differentiate? Supremum, you can't differentiate supremum. One of the problem with K statistics, while it behaves like a distance between PDFs, we cannot compute derivative. That's the biggest problem. We cannot compute. We cannot compute the derivatives of K statistics. The moment you can't compute, the moment you can't differentiate K statistics, you can't use it as loss function in optimization based machine learning models. That's what your logistic regression, linear regression, and SVM, all of these are. Even some of the deep learning concepts that we will study, that we study later, all of them are optimization based, which means I can't use K statistic here because it's not differentiable. So what do I need? I need the distance measure which is differentiable, because the moment this is differentiable, remember, the moment this is differentiable, it is brilliant because I can use it as loss function. Imagine if my model returns a PDF, imagine my yi is actually a PDF. Imagine my yi is probability density function of P of x. Let me assume my yi is probability PDF, yi is probability density function of P of x, and yi hat, this is my yi hat, isn't it? What is my yi hat? My yi hat is the predicted density function, which is Q of x. Now, if I want to compute the loss function between both of them, I can always use distance. If there is a loss function between both of them, that is y and yi cap, it should be differentiable. If I want to use optimization based methods, if there is a loss function between both of them, it should be differentiable. If I want to use optimization based methods, that's where the idea of KL divergence comes. Again, KL divergence has its origin in information theory and physics. The whole concept of entropy itself is designed by physicists in the first place when they studied thermodynamics. Again, the same concept has been borrowed by information theorist like Shannon, a phenomenal mathematician, computer scientist, information theory godfather. Literally, he used the concept of entropy in physics, especially from thermodynamics to information theory. Information theory is a subject that many electronics engineers, computer science engineers, and mathematicians study. The whole concept of entropy that we studied in the context of decision trees, information gain, all of that has its origin in thermodynamics and physics. Just go through this lecture, try to understand this one. Here the biggest problem with K statistics is it has got mod value, which is not differentiable. If it is not differentiable, I cannot make use in problems related to optimization. I cannot make use optimization based method where KL divergence. We will try to understand what is KL divergence in my next lecture, that is in lecture number 394. Time being, just understand there is a drawback with K statistics, that is continuous but not differentiable, but differentiability is required in many optimization algorithms. Thank you very much.